Green chemistry, ibuprofen, a study in green chemistry is one I'm going to go over today. Green chemistry is the design of chemical products and processes that reduce or eliminate the generation of hazardous substances. So before I talk about green chemistry and the production of ibuprofen, I wanted to talk about ibuprofen itself. Ibuprofen is a non-steroidal anti-inflammatory drug that is used for pain relief and fever or inflammation reduction. It was discovered in the 1960s by Andrew Dunlop, who initially tested the drug on cures for hangovers. The drug was first made available via prescription in the United States in 1974 and soon became available as an over-the-counter drug. And below is the formula for ibuprofen. Isobutrophenone synthesis. Benzene underwent a Friedel-Crafts acylation with isobutyryl chloride to synthesize isobutrophenone. The reaction was performed using excess benzene as a replacement for a typical solvent and heat to reflux 88 degrees Celsius for a period of 3 hours. Any unreacted benzene was recovered after the reaction during the distillation process. A 66% yield of isobutrophenone was obtained from the solar synthesis compared to a 44% yield from an in-lab electrical heating analysis. Isobutylbenzene synthesis. From the previous reaction, this certain synthesis underwent a Wolff-Kishner reduction using hydrazine hydrate in strong base conditions to synthesize isobutylbenzene. The solvent for this reaction was replaced with a more sustainable solvent, glycerol. The glycerol for this reaction was obtained from the synthesis of biodiesel. The BHD method, the company developed a new sustainable synthesis that halved the number of synthetic steps for ibuprofen. The first step utilized anhydrous hydrogen fluoride as both a catalyst and solvent, which was then recycled and reused. The reduced amount of unwanted waste was due to the generation of only one molecule of water as the byproduct. And above the ibuprofen in the picture is the synthesis of ibuprofen that was used by that method. Solar energy. A solar reflector was designed through the repurposing of satellite dishes into a reflective parabolic mirror to serve as a sole heat source for synthetic chemical reactions. The heat source was able to synthesize a commercially important pharmaceutical product from a well-known high-temperature reaction. So therefore, the solar energy, the heat derived from the satellite helped produce that chemical reaction for ibuprofen instead of using electricity. Green chemistry in everyday life. One of the first steps for green chemistry is the prevention of waste. It is better to prevent waste than to treat or clean up waste after it is formed. An example of this concept, so when my apartment is typically clean on a day-to-day basis, unfortunately my husband does not like to put stuff away and kind of creates a mess. So if he puts stuff away in the first place, then there wouldn't be a mess for me to clean up afterwards. And this is my works cited page. Thank you.